So next we have linear form of the differential equation, or it's also called as Leibniz form of differential equation. So what are the Leibniz or linear form of the differential equation? These are the differential equations which can be represented this way, right? And how to solve them? There is only one way. Write the differential equation in this format, that is step number 2, step number 1, and the step number 2 is finding the integrating factor. Integrating factor can be obtained using this formula, right? And then you have to identify q. And third one, the solution, you will get it as y into integrating factor is equals to integration of integrating factor into q plus c. So when you substitute the calculations from step 1 and step 2 in this format, that is the solution of the given differential equation. So we have been given this question, dy by dx minus y by x equal to x square minus 2. For sure it is of the form py equal to q. So our p will be minus 1 upon x and q is x square minus 2. Let's follow the steps. So as per the step number 1, we have compared, we have identified the values of p and q, right? I'll write it down over here that you should identify p and q. Next, we'll calculate the integrating factor, that is e to the power integration of p dx, e to the power integration of minus dx by x, which will be e to the power minus ln x, and which can be further written as e ln x to the power minus 1, which becomes 1 upon x. So we have the integrating factor. Now let's write down these values in the solution format. Y into integrating factor, that is 1 upon x, equal to integration of integrating factor dot q. Q we have is x square minus 2 dx. Let's simplify this integration. So x square by x minus 2 by x dx. So this integrating it, so x square by 2 minus 2 ln x plus c. So this is the solution of the differential equation, or even if you want, you can further convert it into exponential format. Let's see what comes up. So y by x equal to x square by 2. This will become minus ln x square, and c also will write it in ln format. So y by x minus x square by 2 is equals to ln c upon x square. So this will be 2y minus x cube by 2x ln c by x square. So if you convert it into exponential format, your answer will resemble somewhat like this, x square dot. So this is also another solution for the given differential equation, either in this format or this form. These are the general solutions. After finding out the values of y and x, if the values of y and x are given, we can find out the constant c, and then the final solution can be found out. So this is another differential equation. If we compare it with dy by dx plus py equal to q, for sure the value of the p would be minus 3 cot x, and the value of q is sine 2x, right? Let's find out the integrating factor cot x dx. So this would be minus 3 ln sin x, integration of cot x is ln sin x. This thing, if we further simplify, sine cube x, and as per the rules of exponents, it will become 1 upon sine cube x. So here we have the integrating factor. Now let's substitute in the solution format. y into integrating factor is equals to integration of integrating factor into q dx. So here now we'll use the substitution method, right? We'll write down, let sine square x equal to t, its differentiation is sine x cos x dx equal to dt. This is nothing but sine 2x dx equal to dt. So this thing will use the substitution. So y upon sine cube x is equals to dt by t. So integrating it, here we have sine cube x. So sine cube x, we can separate it out as sine square x dot sine x. The further substitution would be t and square root of t. Let's integrate this. So t to the power minus 3 by 2 plus 1 and minus 3 by 2 plus 1, and the integration constant will be added up. This will be minus 1 by 2 upon minus 1 by 2 plus c by root t plus c sine cube x. So on further simplification, minus 2 upon sine x plus c. So here just a rearrangement, and y plus 2 sine square x is equals to sine cube x c. So this is the solution of the given linear or Leibniz form of the differential equation. Here we have been given the value of x and y, so we can evaluate. If we substitute the value of x and y, plus 2 equal to c, so we get c as 4. So we can write the final answer as 4 sine cube x. This is what. So at this place we are required to find out. So let's try to arrange it in the linear form. So we have dy by dx is equals to y by x plus log x by x. So dy by dx minus y by x will be equal to log x by x. So here now we'll find out the integrating factor. Integrating factor will be e to the power p dx, and p from the comparison we know it is 1 by x. This thing further simplification will give ln x, so 1 upon x will be the integrating factor. Now let's substitute in the solution. Y into integrating factor is equals to integration of integrating factor dot q we have it here log x by x. So here we'll use the method of substitution. To solve this, we'll take, let 1 upon x be equal to t. We'll take log x equal to t, so 1 by x dx is equals to dt, and from here e to the power t is equals to x. So log x dx, log x is t and 1 upon x dx is dt, and one more x will remain which will be written as e to the power t. So further simplification, to the power minus t. Now u dot v method we will use. So it will be u integration of v minus integration of du by dx integration of v dx. So it would be e to the power minus t by minus 1 dt. Further simplifying, plus integration of e to the power minus t dt y by x, we can substitute the values of t. Log x e to the power minus t will be 1 by x, and this integration will be minus 1 plus c. So y by x minus log x by x minus 1 by x plus c. So y plus log x will be equal to minus 1 plus cx. Right, now here we have been given some conditions, so we'll use that one, y0 and x1. So minus 1, right, plus c. So value of c we got it as 1. We'll substitute y plus log x plus 1 is equals to x. So this is the final solution of this given linear differential equation. So here we have this differential equation, right? From the comparison, we can find out the integrating factor minus 1 dx. So integrating factor would be e to the power minus x, that is nothing but 1 upon e to the power x. Then substituting it into the solution format, it would be, I'll keep it as power minus x and q is sine square x. Converting it into integratable form, sine square x can be written as 1 minus cos 2x by 2. So e to the power x by 2 minus half of e to the power minus x dot cos 2x dx. So this would be 1 upon 2 e to the power x minus half of e to the power minus x dot cos 2x dx plus c. Solving it further, this was minus x, so minus will come minus e to the power minus x by 2, and here we'll use the method of u dot v, right? So u dot v minus half u as it is integration of v sine 2x by 2 minus integration of du by dx dot its integration will be sine 2x by 2. To evaluate this integral, we'll solve it out separately, right? So the writing confusion can be avoided. So this can be written as, I'll solve it separately, this integration cos 2x dx, right? So let's take it as I. So taking at u dot v will be u integration of v minus du by dx and integration of v sine 2x by 2 equal to y. So half of, then this will become plus 1 by 2 integration of e to the power minus x sine 2x equal to y. Further we'll apply u dot v. So u integration of v minus integration of du by dx and the integration of v. So whole in bracket minus x sine 2x, this 2 2s are 4 and minus sign, so 1 upon 4 e to the power minus x cos 2x minus minus plus, so ultimately just the minus remains. 1 upon 2 will multiply inside, so this will become 1 upon 4 cos 2x equal to I. Now right, this term is exactly I, so we can replace it with I. So minus I by 4 equal to I, so this will become I plus I by 4, so it will become 5I by 4. So value of I we got it as e to the power minus x sine 2x by 2 minus cos 2x by 4, and this whole multiplied by 4 upon 5. So let's use this value of I into our solution. So continuing our solution, half of e to the power minus x minus half of, and instead of I, right, we can write it down as 4 upon 5 into e to the power minus x sine 2x by 2 minus x cos 2x by 4 plus c. So either you can leave it in this format, or further if you want you can simplify. We can take out e to the power minus x common. So the solution will get reduced to 4 plus c. So if you want you can solve further, or this is the solution of the given linear differential equation. So this question, once again, it's of the linear form, right? Dy by dx py into q. So this is p and this is q. Let's find out the integrating factor. E to the power integration of 2x by 1 plus x square dx, right? This will be e to the power ln 1 plus x square, and further it will become 1 plus x square. So this is the integrating factor. Let's substitute in the solution format. So it will be y into integrating factor equal to integration of integrating factor into q, and q we have 1 upon 1 plus x square whole square dx plus c. So 1 square gets cancelled out. X square is equals to integration of dx by 1 upon x square plus c, integration of 1 upon a square plus x square, tan inverse of x by a plus c. So this is the required solution of the given linear differential equation. So here we have another question, and this question once again can be converted into the linear format. So dy by dx 5x minus 4y, dy by dx plus 4y is equals to 5x. So once again finding out the integrating factor, 4 dx, so e to the power 4x is the integrating factor. Then substituting it into the solution will be integration of integrating factor dot q dx plus c. So here you can use the method of u dot v, phi common. So u dot v, u integration of v dx minus integration of du by dx and integration of v dx plus c. So y e to the power 4x 5x e to the power 4x by 4 minus 5 by 4, and further integration will give you 16 plus c. Now the conditions, initial conditions are given to us, so we can substitute y0 x0. So this will become 0 0, and this will become minus 5 by 64 plus c. So c will be equal to 5 by 64. Here it will be just 5 by 4 and 4. So 4 4s becomes 16. So we have value of c as 16. So equation can be rewritten as this equation: y e to the power 4x is equals to x e to the power 4x minus 5 by 4 e to the power 4x plus c is 5 by 16. We can rearrange it. So it will be y e to the power 4x plus 5 by 4 e to the power 4x minus x e to the power 4x equal to 5 by 16. Further, if you want, you can take out the step common, and finally you have the solution of this given differential equation.